Okay, so today I want us to look at VLAN. VLAN is one of the important, I can call it technology that is being used, and more so when you want to logically, separate maybe separate traffic. So you'll be applying this. So VLANs, that is the virtual local area networks, mostly, is being created on layer 2 devices. Though I know that even some routers nowadays which can support this, okay, which can support this, but I know mostly our layer 2 devices, including a multi-layer switch, which also is a layer 3 device, also do support it. So if you look at our main objective here, upon completion of this particular module, you should be able to explain how network protocols enable devices to access local and remote network resources, especially with when we have the VLAN created. So we're going to look at all this, the overview of the VLANs, and how basically we can create this all the way to the trunking protocol, which again is very, very important. Dynamic trunking protocols, at one point will be required, especially when when you want to do those remote access on different networks. Then this one will be very, very important here. The dynamic trunking protocols will be very, very important. So with the VLAN definitions, okay, as you have said, it's just a logical connections with the other similar devices. You can just do a logical, a logical connections here. You can do a logical connection. So placing devices into various VLANs, we'll have the following characteristics. That is that segmentation of various groups of devices of the same switches. Yeah, is possible. Okay. So again, in terms of manageability, so you'll be able to manage broadcast, multicast, unicast, by separating them again, each of those devices into different VLANs. Then what we know with the VLANs, a VLAN is creating its own subnet. So meaning each VLAN that you have created must have a unique ID. Okay. Then also there will be that, the kind of domain that will be created. Remember, by default, all the switches will have VLAN 1. So that means what? All the ports that are connected to it belongs to VLAN 1. Right? And now you can decide to separate these ports into smaller VLANs that you have created. It's like partitioning that particular switch, or like a room, and each room now is attached to specific devices. You are creating smaller domains there. So meaning smaller subnets is being created whenever you have this. So what are some of the benefits of having VLAN in place? There are numerous benefits that you can have when setting up a VLAN. So smaller broadcast domains, okay, that is dividing the LAN reduces the number of broadcast domains. By dividing this LAN. That's actually what we have said. So it's smaller domains being created out of one particular domain, one major domain. Remember, the switch is just one, but with several domains are there. That one again will enhance or will improve the security of our networks, because now each of those users will have or will be as different VLANs or same VLAN depending with your configurations there. So only users in the same VLAN can communicate together. Okay. So if we don't belong to the same VLAN, then there's no way we can communicate, because that one can be separated even via the trunk, what to be allowed to go through. Then IT efficiency is another benefit that also we can have, as we have said. When it comes to grouping, you can group those devices based on maybe faculty, students, admin, and other things that you can set up, or other groups that also you can set up. It reduced cost in terms of the number of the number of VLANs, not VLAN rather, but switches that you can have. You don't have to get another switch for you to create all this, because one switch can support multiple of those groups or VLANs. In fact, it can do up to 4,000 VLANs. 4,000 VLANs, just one switch. So with one switch, you are good to go. So you don't incur another expense of getting another switch. Then better performance, okay, because we have said that each group will be on its own or on a different VLAN or a different subnet. So meaning traffic that actually will be generated in each group will be affecting that particular group, but not spreading out. Unlike when we are in one particular room or one particular area, okay, we actually know there'll be a lot of noises and congestions. But in that case now, we will be able to manage all this in terms of performance. Then again, for management or similar management, similar groups will need similar applications and other network resources, depending with actually what you want to do. For example, if you look at it in terms of, let's say, the learning institutions, like let's say like the universities, where we have the regular students, we have distance learning students, what are calling the ODEL, and such. Now you can separate this one with each group now having their own applications running that support them. So meaning you can have like a platform for a given group, let's say the distant learning students and the regular students again, and maybe other groups, depending with the nature of the programs that are there. So those are some of the benefits also that can be implemented. So that will bring us to various types of VLANs, guys, that can be created. Okay, we have what I call the default VLAN. These are VLAN that come with a switch. It's come with a switch. Okay, it's the default VLAN. So for example, the VLAN 1 in that case is a default VLAN. Okay, VLAN 1 is a default native VLAN. It's a default management VLAN. You can see it's almost everything because it's come with that particular device. Okay, and again, you cannot delete or rename that VLAN 1 because it's there by default. So it's something which has been programmed already in ROM. Okay, in ROM. So you cannot delete it. Okay. So while you cannot delete VLAN 1, Cisco will recommend that we assign these default features to other VLANs. So you can set to other VLANs other than VLAN 1. So you can create your own VLAN and you assign it. Apart from the default VLAN, we have also data VLAN, mainly meant for the users or the kind of traffic that we normally generate. So dedicated to user generated traffic, it could be email, it could be web traffic, all this. Okay. So again, you'll find that VLAN 1 is again default data VLAN. Okay, because now all those interfaces also belong to it. Native VLAN used for trunk links only. No, a native VLAN majorly, okay, are VLANs that are meant mostly for the, for the tag, the tag traffic. Okay, all frames are tagged on this particular trunking protocol 802.1q link, except for those on the native VLAN. Meaning, you see on your network there'll be what? On your network there will be traffic, yes, coming in. Those traffic are those which are known from a given group or from a given VLAN. 1, 2, 3. I know this is from VLAN 10. This is traffic from VLAN 20. This one is from VLAN 30. But at the same time, remember, you'll be receiving the one which are not tagged. They are untagged. They're just plain. Okay? So you don't know their origin, their source. So such kind of VLANs are the one being directed to native VLAN. for further examinations. So meaning you can check the native and find out which are these traffic which have been captured here. Okay, then you can allow them in, or you can decide to block them. Okay, are there. Then management VLAN is another VLAN that we have. Remember, we did some management remote access yesterday. Okay, with SSH and even telnet. Okay, and for us now to be able to do so, you must create what I'm calling a management VLAN. Okay, by specifying this the use of SSH and telnet within the VTY. Okay, within the VTY. So again, VLAN 1 is again that, you know, management default VLAN that you can have. That's why you normally assign int VLAN 1 enter IP address, then you put the IP address on that. That one alone becomes a management VLAN. So by default, again, you can set that VLAN 1 as a management VLAN there. So VLANs in a multi-switch environment, you know, you have, yes, VLANs, as you can see, different switches, like I'm also switch 2 and switch 3 here, based on what we have. So you can see there is guest VLAN 30, there is a student VLAN 20, there's faculty VLAN 10. It's the same on switch 3 as well are there. So that means what? Okay, so you have to, of course, there'll be a trunk. In this case, you must have a trunk. A trunk is a link that is connecting switch 1 and switch 2, switch 1 and switch 3. Okay, even switch 2 and switch 3, if at all you want to add another link or cable. So the interfaces interconnecting switches, the interfaces or the links rather interconnecting switches are the one you're calling trunks. They are trunks. So Cisco trunk functions, okay, this way, that is, it's allow more than one VLAN. As a trunk, you'll be receiving traffic from different VLANs. VLAN 10, 20, 30, all of them will be going through the trunk. You can extend the VLAN across the entire network. Okay. Now, like you see, we are now connecting switch 2 and switch 3 on different switches. So meaning we have just extended that one by introducing a trunk. By default, it supports all VLANs. Yes, it do support all VLANs, all the VLANs. It can be allowed, except when you don't want to allow, you want to deny, that's okay. But it can support all the VLANs, okay, all traffic from different VLANs. Then again, you must have 802.1q trunking protocol, because this is a trunk. Mostly when setting a trunk, then this trunking protocol will be enabled. 802.1q will be enabled there. Okay, so imagine a network without VLANs. Okay, so you can imagine the kind of chaos that will be created with such. So without VLANs, all devices connected to the switches will receive all unicast, multicast, and broadcast, all of them, because there's no boundary, and especially when you have the same broadcast domain, one broadcast domain. You know, you can have multiple switches, but all those switches belong to one domain. That is broadcast domain. Yes. Okay. Let's say within Nairobi city, you have branches just within Nairobi. Maybe another one in Karen, another one maybe, you know, in the town center, another one maybe along Mombasa Road, maybe somewhere there, another one, you know. But all of them have been set up within the what? The same domain. So meaning any problems, any experience that, you know, a given part will be experiencing also will be transmitted all the way to another branch. And that's why people tend to separate those particular traffic so that we don't interfere with other devices. Okay, because why should I get your broadcast? Okay, if at all it's your own device which is having the issue, why should it get to switch 2, you know, to switch 1 and such, or to switch 3? So those are things that actually we need to manage. So PC1 sends out a local layer 2 broadcast. Then the switches forward the broadcast frame out all available ports. All of them will be spread out, which again is a challenge, So the only solutions therefore, guys, is just to implement the VLANs. Okay, so with the VLANs, now traffic like unicast, multicast, broadcast will be confined within a given VLAN, and therefore will not interfere with our processes which are running. So without a layer 3 device to connect the VLANs, okay, then devices in different VLANs will not be able to communicate. As you can see, we have faculty VLAN 10. We have student VLAN 20. At what point you want them to communicate? Okay. The one that are on the same VLAN, that one no problem. They'll be communicating with or without a router because we're on the same VLAN. Okay. That kind of communication within the same VLAN is what I'm calling intra communication. That's what I'm calling intra communication. But the one that are on different VLANs, okay, 10, 20 is what I'm calling intercommunication. So that's actually the difference between the two. Intra and inter communications are the two major type of communication that we have based on the network where you are. Are you on the same network? Are you on a different network? So that's actually the point that also I want you to drive home. We have talked of the trunking protocol. So, and you have said each of those VLANs needed to be identified with a tag. So of course, where you are known. You are known, even though you are in different areas, different, let's say ministries, different departments, but you can easily be identified with your what? With your tag, the ID, the work ID that you have or something, okay? Because it is tagged on you, okay? It is tagged on you. Unlike me, when I walk in and I don't have any tag, you see, for me, of course, I'll be subjected to a lot of questionings, where to see who and such, because I don't have any tag, okay? The same way you have in your place of work, unless now also I come and become part of you where you are. So when the tag is created, the frame check sequence, FCS, must be recalculated there. When sent to end devices, this tag must be removed and the FCS recalculated back to its original number. So if you look at this, we have the VLAN field, okay, being actually inserted in between the source MAC address and the type length field, so that at least we can now that VLAN being supported. So in that case, with that particular tag, it will have other subfields, like the priority field, the canonical format identifier field, then with the VLAN ID, and what each of those fields can perform, okay, to make it actually support that tag or the VLAN ID, okay? And especially if you look at the last part, okay, the VLAN identifier, which we said can support up to 1496 VLANs. 1496 are VLANs there. So that's actually to be able to support everything there. Native VLAN, native VLANs and 802.1q tagging. Okay. So 802.1q trunk basics. Tagging is typically done on all VLANs, as we have said. Of course, when you have the VLAN on your network, so expect traffic with the different VLANs, whether it's voice, whether it's data or video. So long as VLAN has been created, it will actually come out with a big event VLAN ID. So again, we have talked of the use of native VLAN. Okay, it was meant mostly for the legacy devices like hub. Okay, but still, as we have said, that VLAN one will still remain native unless maybe you have decided to change it to something else. Maybe VLAN 20 or 30 be your native. So both end of a trunk link must be configured with the same native VLAN. Okay, as illustrated. So each trunk is configured separately. So it is possible to have different native VLANs on separate trunks. So that's actually you are going to look at it. That's how you're going to look at it. So you can have those, trunks as specified here. The trunk, these are trunk, that trunk, that trunk. So if you have a router, up here, a router connecting to a switch, that's a trunk also. That is being created there. So that's the most important bit that we have there. So guys, that's actually what do happen there. Now, in terms of quality of service, in terms of priorities, which one will be given priority in case there's a congestion within your network, okay, between voice, between video, voice, video, and even data, okay, which one actually are you going to give, guys, the priority, okay? So that again depends. So like what we have here is just a diagram with a switch, but also you can see IP phone somewhere connected, and also the PC being set up. So the voice over IP phone is a 3-port switch, okay, what you can see over there. So in that case, the switch will use CDP to inform the phone of the voice VLAN. So what is the purpose of having CDP, Cisco Discovery Protocol? Like, you are informing the switch, you have a neighbor, and that neighbor is IP phone, okay? Informing the PC, you have a neighbor, and that neighbor is the IP phone. So basically, that's actually what we have in place here. That's actually what we have in place by setting this CDP, Cisco Discovery Protocol. It's a protocol developed by Cisco. The phone will tag its own traffic, that is voice, and can set cost of service. Okay, the cost of service is just mainly meant for quality of service for layer 2 devices. For layer 2 devices are there. So you can set the cost of service. Is it cost of service, or sometimes you call it class, class of service are there, okay, being set, because now we have such kind of VLANs. And remember, you want to enable the tracking protocol 802.1q as well are there. So that's really what you're going to have. So the phone may or may not track frame from the PC. Okay, so basically what we have is let's see, voice LAN, VLAN, and access VLAN being specified. Okay, with various tagging functions, you can see what voice VLAN can do. Okay, and the access VLAN will be able to perform there. Okay, so the interfaces. The interface that you have to confirm whether that particular interface is enabled with a VLAN. Okay, show interfaces first Ethernet 18 switch port. Okay, you'll be able to see that, yes, it was enabled with a VLAN or it was assigned to a VLAN, like in this case, VLAN 20 student. Okay, at the same time, also, there's a voice VLAN assigned to it. So meaning that's an interface that generates different traffic. It generates voice. Okay, I mean it has both traffic for voice because of the PC that is there, and for what no for data because of the PC that is there, and for voice because of the IP phone that is there. Just one interface, are there, having all this. Okay, now guys, how do you configure a VLAN? How do you configure a VLAN? So as we have said, of course, various series of switches that we have normally support this VLAN. So 2960 and 3650 support over 4,000 VLANs. Okay, so we have normal range category VLAN and extended range category VLAN. So mostly normal range is meant for small to medium-sized businesses. Okay, and what is the range here? So within that range, if you look at the output, show VLAN brief here, there's VLAN 1 here, which is there by default, and all the interfaces of this switch belong to VLAN 1 by default, unless you want to change that. Then we have other, other reserved VLANs, 1002 to 1005. So meaning within the normal range VLAN, as we have said, so you can create from VLAN 2, because 1 is there by default. So you can create from VLAN 2 all the way to 1001, because the rest have been automatically created and cannot be deleted. 1 to 1002 all the way to 1005. Those ones have been automatically created and cannot be deleted. So that's what is being required. So again, all this is being stored in the VLAN.dat file within the flash memory. Okay, that's actually where you can get all this VLAN file. Then also it supports what I'm calling virtual trunking protocol. Okay, so it can synchronize between switches are there. Virtual tracking protocol. I know later we'll talk more about this VTP as we move on. Then we have extended range VLAN. You see, it is 1006 all the way to 4095. Okay, as the last one. That's why we are saying it can support over 4,000 VLANs. Okay, but it's mainly meant for service providers. So meaning we need to change the mode, the VTP mode, for us now to be able to have this. There is transparent, there is client, and there is server mode. So for you now to configure 1006 onward, then the mode must change. For now, the one that we'll be covering is only supporting the normal range VLAN, but you cannot have anything that is more than 1005. Okay, there. They are in running config file, then support fewer VLAN features, then requires VTP configurations. Yes, we have to, set that. Okay, VTP mode transparent. Then from there, it will allow you to start creating a VLAN more than 1005, 1006, 1007, all the way to 4096. For the ISPs, you understand what I meant. If I told you in the ISP space, and you have been creating this, so that's actually the point there. So creating a VLAN is that simple. It's not that complex. Just need to move to global mode, then specify the VLAN that you are creating. VLAN ID. Then you assign it a name. Can say VLAN 10 name, Unis. VLAN 20 name, John and such, but of course, you have to give a name related to what actually you are doing there. Okay. Is it dealing with students? Then name students. Admin, yes, name admin and such. Then for that, you just need to go back to global mode to see what you have done. So in that way, you can see here. A good example is what they're giving here. VLAN 20 name student. Okay. How about if you ignore to name that VLAN, then automatically it will rename it for you by default with a 3-digit number. Okay. So it will actually rename it for you by default by taking the number. If you had VLAN 20 being created, then you end up having 002. That now will be added to it because you do not give any name. So it's always good to set a name for your VLAN. Having created the VLANs, now it's time to assign the interfaces to the ports. Once the VLAN is created, we can then assign it to the correct interfaces. Okay? Each and every VLAN must be assigned to a given interface. Must be assigned to a given interface. Which interface are you accessing? So you move to a given interface. The commands are given interface with the interface number, the interface ID that connect that particular VLAN or the PC that you want to assign. Switch port mode access. It has to be in the accessibility mode. It has to be in accessibility mode. Then switch port access VLAN, then specify the VLAN ID that you have created. So in that case, we want to see what we have here. Interface first Ethernet 18, switch port mode access, switch port access VLAN 20. Okay, so this is very, very important. You have to change the interface to be in the accessibility mode. Switch port mode access, okay, to be in the accessibility mode. So you can assign the VLAN to the port interface. Once the device is assigned, the VLAN, then the end device will need the IP address info for that VLAN, okay, for that VLAN. So of course, you'll have to set that one. For example, with a student PC, you can see it has, look at the IP address that it's been assigned. So if you look at the third octet, 172.70.20, that 20 usually represents the VLAN ID. The VLAN ID. So VLAN 20.20 is the VLAN ID. Okay, that's actually, you can have those names. And also on the third octet. Then now .22. 22 is now the PC number. The PC number. Okay, that is PC2 number there, 22. So you can have the same 20.23, 20.1, 20.2, etc. Okay, being configured are there. Now, guys, for the case of the data and voice VLAN, and this actually what you have said, yes, you might have different VLANs for the voice and for the data, but at the same time, it's being connected with the one particular one interface. So an access port may only be assigned to one data VLAN. However, it may also be assigned to one voice VLAN for when a phone and an end device are off, okay, of the same switch port. Okay. However, it may also be assigned to one voice VLAN for when a phone and an end device are off the what? Same switch port. So that's actually what we can do. That's what we can do with that. So what does that mean therefore when setting such? Okay. Yes, you have a VLAN that you are creating, as you can see. Okay. They have created VLAN 20 for student and VLAN 150 for voice. Okay. So again, in addition to assigning the data VLAN, we will also assign voice VLAN and turn on quality for service for the voice traffic to the interface. So what does that mean? especially if we are sharing different traffic sharing same interface. What does that mean? Okay, so the new catalyst switch will automatically create the VLAN if it does not already exist. Okay, the new switches that we have, that is if you don't now create. For example, we have gone ahead and set interface bus Ethernet 18, switch port mode access, switch port access VLAN 20, and you did not create that 20. So with the newer devices, it will automatically sense and create that one for you. That one for you. So quality of service is beyond the scope of this course. Here we do show the use of MLS, that is multi-layer switch with quality of service trust, okay, class of service or cost of service they are being set as you can see. Basically what we have here on this interface 18, okay, you are now allowing, you can see switch port mode access, VLAN 20 on the same interface. Then you have switch port mode voice VLAN 150 also is there, also is coming there. So because now this will be, generating different traffic based on the VLANs you have set, okay? So that means therefore, which one will be given priority in case of any condition being experienced there? And again, you're telling the interface to trust, okay, the traffic that actually will be created here, and more so within the voice, within the voice there. That's what actually what we are trying to set. Trust, okay, M or multi-layer switch, quality of service trust, class of service or cost of service, traffic, okay, trust. So you are trusting because that two different conflicting, traffic for the same interface. So informing them, the interface, please trust those traffic that you are receiving are there. Okay, because if you don't, then you'll find that there'll be some sort of, issues, the trust issues with the traffic that are being created. Okay, so that's actually what you are trying to state there. And remember, these are layer 2. It's a layer 2 device that is doing all this are there. That's doing all this for us. So that's the point actually. So if you verify, show VLAN summary, you'll go to the number of existing VLANs, number of existing virtual tracking VLANs, number of existing extended VLANs, if at all they are available. So remember, it will consider the default VLANs which are existing now plus the one that you have created. That's the point. That's why you'll find that the existing VLANs are 7. And maybe you had only created 2. Okay, 2. So, but where are the rest coming from? Okay, where the rest coming from? So it will actually consider the one that already are existing by default again. So that's the point actually. So again, if you look at those commands that we have talked about, display VLAN name, status, and export 1 VLAN per line, then show VLAN brief is the command that actually can have there. Display info about the identified VLAN ID number, VLAN ID will be used. Display info about the identifier VLAN name, the VLAN name, okay, will be used there. Or you can have the summary. Display VLAN summary info, then you can have show VLAN summary are being used. So it depends basically with what we're trying to check within your switch there. Then port membership. Yes, you can reassign. I'd assigned you your VLAN 20. I'd assigned you to port 18. I can change the port membership and assign you to a different port number, maybe port 20, maybe port 1, because these are 24 switch port. So I can have any port number, okay, being reassigned to you. And therefore, for you to be able to do so, it's quite simple. You just need to remove, okay, what you had assigned. If you are on that particular interface, maybe for example, interface first Ethernet 18, enter. No switch port access VLAN, then you specify the VLAN. You specify the VLAN. So you are removing it. You are removing it. No switch port access VLAN. Okay. So you are removing that one. So it means you are removing a given VLAN ID from a given interface and have a new one being set. And by the way, anytime you tried to assign a VLAN, let me see here. Whether it has been explained or not yet, but I think we'll be able to do it practically and we'll be able to understand that. So anytime actually you set that, guys, you'll find that the interface that you have used will not be available, will not be among the one available on VLAN 1. It will be removed completely and being, okay, aligned or taken against the VLAN ID you have created. If you say, for example, first Ethernet 20, okay, is what you have used. This 20 will be removed from here, from the list, and being brought down here. Okay, so it means it is active and being used by another VLAN, by another VLAN there. Yes, do you want to delete a VLAN? You can use the command no VLAN, VLAN ID, no VLAN 10, no VLAN 20, as simple as it is. Where do you create this VLAN? Okay, you actually created it on a global mode. So you just move to global mode. Don't remove or don't be on a mode where you did not create it. Let's say you want to be in privilege mode or user mode and you're saying no VLAN 20. So the question is, did you create it there? Of course, no. It was created under the global mode. And that's why you must be on the interface or on the mode where you had created that particular task. Caution, before deleting a VLAN, reassign all member ports to a different VLAN. Yeah, this one is very common. Otherwise, the port will be inactive. So you are wondering, how comes some ports are not working? Usually, this is the point. I want to do away with you, with the VLAN, with the VLAN. So I want to remove you completely. So before removing you, I must remove all the interfaces that were assigned to it. If it's 1, if it's 20, I must remove all of them. Then after that is when I go back and do what? And delete the VLAN, no VLAN 10 or 20. So delete all VLANs with them. So in case you want to delete everything within the flash memory, the command is delete flash :VLAN.ead or delete VLAN.dat command. Okay. Then reload the switch when deleting all VLANs. Okay, you'll have to do a reload. So to restore to factory default, unplug all data cables, erase the static configurations, and delete the VLAN, then reload the device. There's another way you can go about it. So those are the major things that we have there, guys. Those are the major things that we have there. Okay. Now we'll talk about trunks as well. No? Trunks. Yes, trunks needed to be set up, needed to be configured. You have to set the trunks as well. So, and to set a trunk is very simple. Just need to check which interface do you want to define as a trunk. Move to global mode. Move to global mode. Then with the interface number, if it is interface 02, 03 that you want to make a trunk, fine. Switch port mode, trunk, switch port trunk native VLAN. So this is actually the point where the native will be defined. So remember, a native is more of a central and it will be accepting all the traffic from different VLANs, both tagged and untagged. So why setting native? Setting native on that particular interface just in case there'll be the one that has not been tagged. It will be directed to the native, okay, trunk. So specify the list of VLANs to be allowed on the trunk list. Yes, we can also do so. Which VLANs do you want to allow? Port trunk allowed. Okay, then allowed VLANs, then you list those VLANs. VLAN 10, 20, yes, you'll be able to do so. Okay, or you can just simply space those ones. So so this is the point. This is the point. After setting the trunk, so remember the trunk, let me remove this. The trunk is the port connecting switch 1 and switch 2. And you want the traffic from different VLANs, 10, 20, 30, to go through. Assuming it's another switch that we have there. Assuming it's another switch that we have there, or another PC connected to switch 1 on the other side. You see, this your trunk here is what you want to specify. So interface 01, switchport mode trunk, switchport trunk native VLAN 99. Switchport trunk native VLAN 99. So it means your 99 is a native VLAN. But you had named it. Okay. That is VLAN 99. Enter. Name native. Name native. Okay. So it is known as a native VLAN 99. And again, something to note, guys. If you have more than one native on different networks, then you must use a similar VLAN ID. Let's say on switch 1 and switch 2 or switch 3. You cannot have different mismatch or different VLAN IDs serving as your native. They have to be same on both switches. So native VLAN 99, okay. Then what to be allowed 10, 20, 30, 99. Okay. So if let's say guests VLANs 50 is not allowed, then it means you cannot communicate on this network. Okay. You're trying to restrict some group are there from communicating with other devices there. So it means they cannot be allowed to move remotely to a different network because that's what has been specified. So you'll be just local at the local level. Okay, you can just communicate at the local level, but not going through. So still that is possible. You can set at that one. So you can confirm whether you have set up the native VLAN on the native or the trunk there. Switchport mode trunk, you can see if you want to remove it. No switchport trunk native VLAN 99. If you want to remove that's okay. Okay, that will be okay. There. So you simply set up that. So if we check on the interface here, show interface first Ethernet 01 switch port, what are you able to see? So you're able to see that here, that particular interface is set to trunk. Okay, and that's what we have here, administrative mode trunk, this interface, because you see switch port mode trunk, interface 01 switch port mode trunk. So your administrative mode will be trunk. Okay, then again, something to note is set as trunk operationally functioning. Okay, it's okay, it's working. That is operational mode trunk. It is functioning. Operational mode trunk. Okay, encapsulation is .1Q. Okay, that one has also been set. That is operational trunking encapsulation .1Q are there. Native VLAN set to 99. Okay, okay, but you know the problem you did not name it, and that's why it's getting that VLAN 0099. That's the name given to it by default. Then all VLANs created on the switch will pass traffic on this trunk. Okay, that is what we have down here. Trunking VLANs enabled all. Okay, so pruning VLAN enabled. So you can see the one that you're able to create from 2 all the way to 1001, meaning they have left out the default one. 1002 all the way to 1005 have been left out. So we have now the pruning VLANs enabled. In that case, is 2 to 1001 there. So that's the most important thing you need to understand whenever setting the VLAN. So you can reset the trunk to the default settings. Yes, if possible, you can set that. So this way, okay. So remember, initially this interface was not a trunk. It is you who set it as what? As a trunk. But you can reset it. Reset the default trunk settings with the no command. All VLANs allowed to pass traffic. Okay. Native VLAN equal to VLAN 1 because it's now going back to the default settings that you had before starting anything. So by removing it, then it means you are resetting everything. No switch port trunk allowed VLAN, no switch port trunk native VLAN. So everything is now going back to its default number. So so what we have, you can now set it back to accessibility mode. So it will become static access. If you look at the administrative mode, it was trunk. It was trunk. But now setting it back, to another mode, then it becomes static. So reset the trunk to an access mode with a switch port mode access. So this one is particularly setting it to an access interface, as you can see, to be administrative and also to be operational there. We have talked about the DTP, Dynamic Trunking Protocol. It's one of the protocols which was developed by Cisco. This DTP has the following characteristics. It is on by default on all our Cisco series switches, 2960 and 2950 series. Dynamic Auto is default on 2950 and 2960 series. May be turned off when the no-negotiate command may be turned off. May be turned off with the no-negotiate command. Okay, if you want to disable the trunking mode, okay, you don't want the two switches to negotiate so that they can form the trunk without your knowledge. Then you need to switch it off so that you can set that trunk manually. Okay, you can set it manually. So switch port mode trunk, switch port no negotiate. That's the command. Okay. So setting a switch to static or static access will avoid negotiations issues with the switch port mode trunk or with the switch port mode access. So you switch it off. Okay. Then when you want it back, when you want the trunking mode to be back, okay, then you can enable it with the command switch port mode dynamic auto. Okay, dynamic auto. So that's what they're saying, may be turned back on by setting the interface to dynamic auto. That is the DTP, the dynamic trunking protocol. So, but there is another common question usually being set in certification exams. Okay, usually being set to certification exams. So again, be careful this kind of commands, especially in dealing with the DTP. Okay, so negotiated interfaces modes. So the switch port mode command has additional options that can be set. When you just do switch port mode space question mark, switch port mode space question mark, what are you able to see? Yeah. So use the switch port no negotiate interface, okay, command to stop, as you have said, DTP negotiations. Yes, it's possible. You want to stop those kind of negotiations without your knowledge. So you disable this using non-negotiate. Okay. But now with the mode, switch port mode space question mark, you can have switch port mode access, switch port mode dynamic auto, switch port mode dynamic desirable, switch port mode trunk being set. So all these are some of the more options that are available with the mode. Okay, so when you say access, permanent access mode and negotiates to convert the neighboring link into an access link. So access. Dynamic auto will become a trunk interface if the neighboring interface is set to trunk or desirable mode. So we have those combination of modes that can form a trunk, that can form access mode. Okay, we are going to look at them in a few. Dynamic desirable actively seeks to become a trunk by negotiating with other auto or desirable interface. So which one will form a trunk? Which combination will form a trunk? Trunk, permanent trunking mode, and negotiates to convert the neighboring link into a trunk link, into a trunk link are there. Okay. So if you look at now, the table summarizes what you have talked about. This table summarizes what you have talked about. So assuming this part running horizontally is switch 1. This one vertically is switch 2. So when you have auto, switch port mode auto on switch 1 and switch port mode auto on switch 2, that one you're forming the access. Okay, access. When you have auto dynamic desirable trunk, auto trunk, auto access. Okay, dynamic desirable auto trunk, dynamic desirable trunk, dynamic desirable trunk, dynamic desirable access. When you have trunk auto trunk desirable trunk access limited connectivity. Okay, access auto access desirable access trunk limited connectivity access. So this table now summarizes all those stories that we're talking about in the previous slide here. Okay, all these are now being summarized with this particular table. So if you want to form a trunk, if you want to form an access port, access rather, check those combinations, because again, I can assure you these are the common questions normally they do bring, but not you to set, but setting more of an application. So engineer so and so wanted to set this, okay, but due to the exhibit that has been captured, okay, he was not able to do so. So what is your advice? Then you're being given those choices there. Okay, that is what is supposed to do. So, but that one is only possible if you're able to understand all these modes and how they're operating. So you can verify the DTP mode using the command show DTP interfaces are there, as you can see being illustrated. But best practice recommends that the interfaces be set to access or trunk and to turn off DTP. That's the best practice. That's the best practice that they always encourage you to do. Now, allow me to go to packet traces, and now let's be practical on what you have talked about, here. Okay. Now, I'm going to have a switch. I'm going to have an end devices. I have this PC, I have this laptop, I have this laptop, I have this server. Okay. I'm going to connect them. Okay, are we still available? Okay, are we together at that particular point, guys? Please confirm if you are okay with that. Okay, good. So we have this this being said, please take note of the interfaces you are configuring. So 01, 01. For that consistencies, I'll use 01, 02, 01, 02. On this end, I'll use 03. On this end, I'll use 04. Okay, so I have my 1, 2, 3, 4. Then this is how I want it to be. For PCs here, I want to put them under VLAN. I want to put them under VLAN 10. Or yeah, I can do VLAN. I can do VLAN 10 there for that, and the other one I can do, I can do VLAN maybe 20. So VLAN 10, VLAN 20 is what actually I want to set up for these particular interfaces, and maybe, yeah, with the subnet, because now you have a VLAN, so it means they'll be on separate VLANs. So let's say VLAN 10, okay, and I can give 172.17.10. 10 is the VLAN ID, prefix 24, okay. And I copy this, Control C, so that I can have another one here. I paste, then I can have this side, can have VLAN 20, 20. Guys, .0 is something I'm missing out, because this is just basically the network. 20.0 because of the network, and I can move to the other side, this one, and have that .0. Sorry, .0. I'm adding there. I'm adding there. Okay, guys. 20.0, 10.0 on the other side. So look at our interfaces and how we are going to configure them. So this, I can call it this PC 0, laptop 0, laptop 1, server 0. Okay, will be in different VLANs there. So I can go ahead and set that. Okay. So show VLAN brief. Show VLAN brief. So if you check on this, guys, you'll find that these are a normal range VLAN that we have being covered in this column, and all these interfaces 01 to 024, including G01 and G02, are within VLAN 1. Okay, those are the default VLANs, including 1002 all the way to 1003. Okay, are also being provided there. Okay, so depending on the number of VLANs that you're going to create. So when counting the number of existing VLANs, they will count even the ones which are there by default. That's why, remember, when we were checking the other one, remember they had 2 VLANs created, 10 and 20. 10 and 20. And as per the output, they were talking of 7 existing VLAN. So it means they were counting these are how many? 1, 2, 3, 4, 5, plus 2 that you had created, okay, as your existing VLANs are there. So config T to move to global mode, VLAN 10, okay, name students, okay, enter, VLAN, can just scroll up this one, VLAN 20. Okay, name, the faculty. Remember, these names are case sensitive, especially if you are doing an exercise that you have been given already, already designed for you. So you must use what you have been given. But if you're just creating your own, then you are free to use whatever you want are there. Okay, so I've just created that. So if you do show VLAN, brief, just to confirm, you'll find that, okay, you have the two VLANs created by default. Yeah, and they are active, by the way. Okay, but not yet assigned to any of these interfaces. Okay, so let's go ahead and now assign the interfaces to these VLANs, Okay, so because 1 and 2 are accessing VLAN 10, 3 and 4 accessing VLAN 20. So I can have them as ranges. I can do range for those. So I can now go back, exit, interface, range, first Ethernet 01, 1, 2. As you can see, 1, 2, 1 to 2, 1-2. Okay, enter. So I'm dealing with the range there. Switch port mode access. But an access port is a port connecting end devices, the PCs, to the switch. We call them access port. We call them access port. Okay, enter. Then I can do the other one. Then switch port access VLAN 10. VLAN 10. Okay, VLAN 10. Then scroll up. The range 3 and 4. 3, 4. Interface range, first Ethernet 3 to 4. Enter. Switch port mode access. Scroll up. Switch port mode access. Yes, we need to change it to be in accessibility mode. Switch port access which VLAN? Switch port access which VLAN? VLAN 20. VLAN 20. Okay. And by the way, still, even 3, 4 can access VLAN 20 if you want. In fact, all the interfaces that you have, first Ethernet 01, 24, you can put them under one VLAN, 30, for example, if that's what you want. Okay. Then, in that way, exit. Okay. This way, guys, you'll be able to move. I'll be able to move to this. And do the interfaces here. I mean the IP. Let's see IP configuration 172.17 .10 of this. Okay. Add talked of prefix 24. By default, it's a class B IP address, and the default subnet mask for class B 255.255.0.0. So I'll be doing 255 there. Okay, there. So for now, I don't have any default gateway, but I'm coming to it in a few. Okay, so I'll close this. I'll do the same. I wish I'd copied instead of typing, but it's okay. So 172.17.10. Can I do .11 because the other one was 10.10. Okay. Yes. Then then we have 255 being added here. Okay. I can Control C, because I want to use it somewhere. I can close this, I can close this. Let me move to the laptop here. Desktop IP configuration, then switch. So I'll put this is 20. 20.10, 20.10. Okay. Then I'll do here. I'll do 255.255.0. Okay. I'll move to the other one, the last one, server. My server, desktop IP configuration. I'll do now 20. I can do 20.11 because the other one was 20.10. Then I can do here 255.255.0. Yep. Okay. So what are we expecting here? What are we expecting? So we're expecting PC 0 and this laptop 0 to communicate because they are the same what? VLAN. Okay. So I can go to the first PC on ping 192, sorry, 172.17.10.11. So I expect them to communicate because we are on the same mode. We are on the same VLAN. So this kind of communications is now what I'm calling intra-communication, because we are on the same VLAN. Then now, can I try and ping? Okay, let's also move and see the laptop and the server. Yes, they are on the same. They're on the same VLAN 20. Let's see what we're going to get. 172.17.20.11. Yes, we expect also the two to communicate, intra-communication. Now, guys, let's try and see the one that are on different VLAN. Let's say PC0 on VLAN 10. We need to be able to communicate with the server on VLAN 20. So I'll go back here and have the IP address, was it 20.11 for the server? Okay. So let's see. Okay, maybe it will communicate, I don't know, but let's give it time. The kind of packets that we are getting there. You can see definitely the two cannot communicate because we belong to different to different networks or different subnets are there. Okay. So yeah, so that's how the two are working. But does it mean they cannot communicate? Does it mean they cannot communicate forever because they don't belong to the same network? Okay, no. They can still communicate. Okay, so that way now we need to add the layer 3 device, and therefore the beauty about, I was supposed to be on the meeting at 4:40. I can see it has been okay, so I'll be joining at 5. Okay, this is now good, so I can use the remaining minutes to do the rest. Okay, that's good. So now it means now for the two devices that belong to different VLANs to communicate, now we need a layer 3 device. Okay, and therefore the next module, inter-VLAN routing, is covering that. So let's discuss about inter-VLAN routing, then we can now come back and finalize that and see how the two devices on different VLANs will be communicating. So inter-VLAN routing, okay, is actually where you can set the PCs that are on different VLANs to communicate. So we're going to look at various, operations for this. Okay, inter-VLAN routing operations. We have different types of inter-VLAN routing. The most common one is route on a stick and inter-VLAN routing using the layer 3 switches. Okay, that's the most important thing that I want to take note of. The other one is just legacy, and legacy is nowadays not in use. So when it comes to inter-VLAN routing, what is this inter-VLAN routing, guys? So basically, as we have said, the inter-VLAN routing is the process of forwarding this particular traffic from one VLAN to another, okay? But the one that are on different subnets or different networks. And in that case, we have three major types of this inter-VLAN routing: legacy inter-VLAN routing, root on a stick, and layer 3 switch, okay, being used. So the most common one are the two, okay, the last two, that is the last two, root on a stick and layer 3 switch. They're the most common one. Now, if you look at the first one, I'll not emphasize on it. I'll just give a briefing on it. Is that now, why was it a challenge? And why did they opt to do away with it? Because the legacy, each VLANs that you were creating, okay, were depending on the interfaces on that router. You can see G000. If you create two VLANs, it means VLAN 10 is meant for G000. VLAN 20 is meant for G001. You see that way? So how about if you have VLAN 30, and this switch is a kind of a fixed kind of configuration switch. It can only support two interfaces. So it means you are limited because you cannot create anything. And that's why it's no longer being implemented because of that limitation. So we were not going to talk more about it. Now, the next one, router on a stick inter-VLAN routing is still okay. Okay, even though it has its own limitations, but at least it's better than the first one, legacy. Okay, now with the router on a stick is that you can take one interface, just one interface, and split it. You split it into smaller sub interfaces to support the number of VLANs that you have created. So therefore, it means each of those sub interfaces that you are creating becomes the subnet of those VLANs that you have created on a switch. That's why it is still being recommended. The only challenge is that it cannot do more than 50 VLANs. Okay, each of those sub interfaces that you're going to create cannot do more than 50 VLANs. But at least, you know, if you have like 30 VLANs, 40 VLANs, still it can support. We call it router on a stick. Then you must enable the trunking protocol using the trunking protocol 802.1q. Okay, very, very important, because now you are now creating remember, a trunk between a router to a switch. It's a trunk you are creating. And you want also, out of the main interface, you want also to create a sub interface, which again will be supported here. So a sub interfaces are configured in software on a router, and each sub interface independently configured with an IP address and a VLAN assignment. Okay, so sub interfaces are configured for different subnets that correspond to their VLAN assignments again. So that's actually why it's still being used, okay, and a bit friendly out there. The other one is router, not rather than a stick, but a layer 3 switch, a VLAN, inter-VLAN routing on a layer 3 switch. Okay, now the beauty about this is that you see this now a multi-layer switch being used, okay, which is the modern method of doing this inter-VLAN routing, okay, and of course using the switch virtual interfaces. So in that case, your switch virtual interfaces is what will be configured with the IP address. So it will act like an interface connecting a router to a switch. But in this way, you have a switch, multi-layer switch, and a LAN switch. Multi-layer switch and a LAN switch, okay, are there. So again, sometimes people call it, layer 2, sometimes people call it a multi-layer switch, so a layer 3 switch or a multi-layer switch, okay. So the term layer 3 switch is common, okay, it's common. And the beauty about this is that it operates in both two layers, layer 2 and layer 3. Layer 2 and layer 3, okay. So let's see router on a stick, the one that already I've talked about. So you can see, you set the trunk, okay, you set the trunk G001 connecting to first Ethernet 05 which is also serving as a trunk. Then sub-interfaces. Out of the main interface that you have created, you must come up with a sub-interface. How do you set a sub-interface? It is the main interface dot the VLAN number that you have created. That one makes a sub-interface. That one makes a sub-interface there. So now, this way you can see we have already created 3 VLANs. Okay, so it means, therefore, we can have 3 sub-interfaces being created. Okay, forget about this start here. These are a typing error. It's supposed to be 99, just like the rest. Okay, so you are creating that, become a sub interface, become a sub interface. Okay, so what are the steps now for creating this? So it's very simple, guys. Already we have one in place, the VLAN that we have created, so there's nothing much. So already we have created the VLANs on our switches and giving them the name and assigning the interfaces to those ones, and that's what they're trying to explain. You start by creating the VLAN. VLAN 10, name LAN 10. VLAN 20, name LAN 20. VLAN 99, name management. That's fine. Then you can go ahead and set a management. There's a management VLAN also that they have created here. Interface VLAN 99 is a management VLAN that they have created. Okay, the IP address. Okay, you're assigning it there. The default gateway, which will be the sub interface of one of the interface IP address up there. Okay, so you can save the default gateway in case you'll be accessing it from a different network. Okay, then your interfaces and how you have assigned them to various VLANs, like interface first Ethernet 18, switch port mode access, switch port access VLAN 20, and such. That's what we have done there. Then again, we must go ahead and set the trunk. Okay, for our case, we have not yet set one, but we're going to set the trunk as well when we'll be configuring that there. Then when you are through with that, you go back to the router, which you need to add. Then this time around, I know you have used to configuring that interface as the whole, as the main interface, G00 or G001. Fine, no problem. But because you have introduced the VLANs, so you need to reconsider the sub-interfaces. So meaning the main interface will not be assigned with the IP address, will not be assigned with the IP, the main interface. The one that will be assigned with the IP address is the sub-interfaces, okay? And for that particular IP address to be accepted, so it means those sub-interfaces, will be enabled with the trunking protocol, encapsulation.1q. Okay, this command configures the sub-interface to respond to 802.1q. Okay, so the keyword, the native, also will be used whenever creating such. Okay, whenever creating such, then the IP address for that particular sub-interface now will be used there. So that's the most important bit that guys, I want us to understand whenever configuring that. So let's look at the example of that. Interface G001.10 is a sub-interface, yes. Then encapsulation.1q10, that's the tracking protocol that we have talked about. Then the IP address. Failure to put this encapsulation.1q, the IP address won't be allowed within that particular sub-interface. It won't be allowed. So you must have it. Okay. There's something again that you need to note. You are not enabling the sub interfaces. Remember, those sub interfaces are in down mode, just like the main interface. But you're not going to have the command no shutdown in the sub interfaces. You just go ahead and set your interfaces, yes. The sub interfaces with the IP address, yes. But now, when you want to enable those sub interfaces to be up, then you will go back to the main interface. Interface G000, no shutdown. So meaning the main interface won't be assigned with the IP address. It's the sub interfaces that will be assigned with the IP addresses. So if you confirm, you'll find that now the PCs now will be able to communicate, even though they are on different networks, but now they're communicating. Like you can see, this is now VLAN 20.10 communicating with the 99.2. Okay, because of those, layer 3 device which has been added there. Now, inter-VLAN routing using layer 3 switches. So yes, we can also set a layer 3 switch using this, and this one is very straightforward. It's not even complicated, just like the router. It's very straightforward. Whenever dealing with a layer 3, it has various capabilities. Okay, it has all the ability to route from one VLAN to another using multi-layer switch virtual interfaces if configured. Yes, you can convert a layer 2 switch port to a layer 3 interface using the routed command. We know very well that the IP address or the interface of the switches cannot be assigned with the IP addresses. And I hope you have tried this one before. Okay. But now you have no choice but now to assign them with the IP address on the interface that you're going to use there. And for it to be assigned with an IP address, then routed port will be used command to convert it to be a physical port from the virtual port, are there. Okay, so to provide the inter-VLAN routing, layer 3 switches use switch virtual interfaces, and these switch virtual interfaces are configured using the same inter-VLAN. Okay, command are there. Okay, so the layer 3 switch virtual interface must be created for each of the routable VLANs are there. Okay, so if you look at the scenario that they're giving out here, okay, am I still audible? Please confirm, guys. Am I still audible? Thank you. So if you look at this scenario, where actually they have the D1, which is the multi-layer switch, and with the PCs1, PC2 being set. Okay. So they want now to see how you can set that. So layer 3 switch configuration. So complete the following step to configure switch with VLANs and trunking. So you can see, of course, you're setting now the VLANs 10, as you can see. Okay, you can set both as you can see there. Okay, create the switch virtual interfaces. Yes. Okay. Then you assign those ports to various VLANs that you have created. The same way actually, guys, you have done the previous one. But remember, switches don't have the routing enabled by default. So it is you to enable the routing on a switch using the command IP routing. It's the only way now they'll be able to communicate. If you don't enable the routing, then that is it. Even if you have done the right thing, the VLANs will not be able to communicate there. Okay. Then if you verify, you'll find that now they should be able to communicate without any problem there. So now I've talked of a routed port. So take of this, this is a router and a switch. G00 on a router being connected to G00, maybe 1 on a switch. But now remove that router and replace it with a switch, a multi-layer switch. So take any interface. Sorry guys, welcome back. Sorry for that. So I was talking of taking a layer switch, connecting to a layer 2 switch. So remember, these are switches, and you want to form this to be a trunk as well. So in that case, you want that particular interface of that layer switch to be accepted, okay, or actually to have the IP address, to be configured with the IP address. The command no switch port will be used. So that will make it to be able to operate, okay, normally just like the router, normally just like the router. So the no switch port interface command in that case will now convert the layer 2 port into a layer 3 interface. Then the interface can be configured with IP4 to connect to a router or to another layer 3 switch. So it will just work without any problem there. Okay. So that's actually the point, as you can see here. Okay, if you want to assign this with the IP address, this G101. Okay, so G101, that is interface, enter, no switch port, enter. Then go ahead and assign the IP address. It will accept, okay, because now you have converted it to be a routed port, So it will accept the IP, it will accept the IP address. So in our case, we're assuming they've done the routing protocol like the OSPF. Okay, so our interest is to just confirm the D1 that you have configured. Are they communicating or something? Okay, so that's the most important bit there. So the commands are given on how you need to go about this one. Complete the following step to configure D1 to root with R1. So configure the routed port. You use that command, no switch port, convert the port to be a routed port, then assign the IP address as a bit mask. Then enable routing, IP routing on a global mode to enable the routing protocols there. Configure routing, use an appropriate routing method. In this example, single area OSPF. Okay, I know that's what we'll be doing in the next level, CCNA 3, about the OSPF. Now, at the end of this, I know towards the end of this, we'll also be introducing routing topics there. Verifying routing protocol, show IP route just to confirm the kind of routing protocols that has been configured, whether it's static or dynamic. Yes, we'll be able to see that one as well. Then you just now confirm that everything is set. Okay, so a good example is this packet trace activities that they have given explaining the process of configuring a layer 3 switch. Okay, being set to a VLAN routing there. Okay. Now, when it comes to troubleshooting, sometimes you might be wondering what is happening. What is happening, right? What is happening? So you might have inter-VLAN issues sometimes. Missing VLANs is one such. Okay, you're wondering how comes you're not communicating. Okay, maybe because you did not create the VLANs. So you need to create that VLAN. The command that can help you verify that, show VLAN brief, show interface switch port, and the ping command are there. Okay, so switch port or switch trunk port issues, then check whether you have set those trunk as defined. So ensure trunks are configured correctly. Ensure port is a trunk port and enabled. The command that can help you to go about that is show interface trunk, show running config. Then switch access port issues, yes, you might have also that one as well. Did you set the mode as access mode when we were configuring that interface? You need to check on that. Did you assign that, interface to a given VLAN number? You need to confirm all this. Okay. So that's the most important thing, how to fix it. You should check how to fix it. So you need to confirm all this. To verify all this, the command show interfaces switch port, show running config interface, then IP config commands are what are available to be used there. Then you might be having some router configuration issues. How did you set your router? Okay. Did you set the sub interfaces at all? If at all you are setting router on a stick, did you create a sub interfaces? Okay. Then if no, you have to go ahead and check on that. Then did you assign that sub interface with the correct VLAN ID number? So remember, encapsulation dot 1Q 10. 10 in this case represent the VLAN number you had used. So there must be matching whenever doing this encapsulation protocol. So there must be a match between the VLAN ID you had created on a switch and the VLAN ID you are now assigning on a router or your sub interface. There must be matching. So if you want to check whether that one has been done or not done, show IP interface brief command still can give you that, or show interface command will be able to give you that as well. So those are the major things that we need to understand. So if you look at these examples that we have, explaining all this concept, okay, to find out what the problem is. So to find out the missing VLANs, okay. Now it's a problem here, missing VLANs. Where are the VLANs that you had created? Okay. Remember what we said, you might end up removing or deleting VLANs with all the interfaces assigned to it. What do you expect? Those interfaces which were assigned that particular VLAN will be inactive, and therefore no communication will take place. So what you need to do, you're supposed to remove all those interfaces assigned to that particular VLAN before deleting that VLAN. You remove all of them, then you remove the VLAN. That one is okay. That one is okay. Or alternatively, recreate that VLAN. Then automatically it will have those interfaces again assigned to it are there. The trunk port issues, as you have said, yes, maybe you do not define the port as trunk, and therefore there's no way the two will be able to communicate on both devices, switch and a router. So you need to check that it is there and enabled. It is there and enabled. Okay. So confirm that yes, your interface has been set as a trunk and it is working. For example, show interface trunk, the mode is on, as you can see. Encapsulation.1 queue was enabled. Status trunking is okay. Native VLAN, okay, is 1 assigned to it. Okay, so that's the most important bit that we need to understand. It could be switch access port issues, as you have said. How did you assign these, interfaces to the VLANs that you have created? Okay, so which one access what? Okay, for example, you see, by just looking at it, there's no VLAN which is assigned. The one that is available is VLAN 10 by default. How about other VLANs? Okay, meaning you did not set that. Okay, so a common indicator of this issue is that the PC having the correct address, okay, but unable to ping its default gateway here. Look, because of what you had set, is because of what you had set are there. Router configuration issues, yes, you can have that one as well. Okay, look at the mismatch of the VLAN ID. Router interface VLAN, the interface that you had set, VLAN 10. So on a router, instead of doing 10, you have done 100. So there's a mismatch of the VLAN ID. That's more of a router configuration issue. So it's a mismatch. So you need to rectify that so that at least they'll be able to communicate there. Okay, they'll be able to communicate. So all these are just some of the labs that are available, both as syntax checker and packet tracers that you can do there. Okay, so I was just connecting the two, VLAN and inter-VLAN, so that I can now go back as I went up this in the next 10 minutes, then I can leave for my meeting. Now I'm introducing a router here. This router of mine is 4331 router, any router series. Okay. Then I'm bringing in G00 to G01. I'm doing a router on a stick. Okay. And now because I've introduced, where did I, oh, sorry. first Ethernet 05. Let me use the Ethernet port 05 here. Okay. Or either way is okay. Even G01 that I've just dropped still is okay. Nothing to worry about. You can just use any of those interfaces. Then I can do here, I can now go to router and set, okay. Okay, no, enable config T interface. Okay, so remember, how many VLANs have we created? 2 VLANs, 10 and 20. So how many sub interfaces are we going to create? 2 sub interfaces, okay, in each network. So the first one, how do we create sub interfaces? I'm going to have G0 stroke 0 stroke 0 dot 10 for the first sub, no, for the first what? VLAN, okay, for the first VLAN sub interface. Then IP address. Then we have 172 dot 17.10.1. Remember, we had not used the first one, so .1. Then 255.25. Okay, there's a mistake here. I want you to confirm this. There's a mistake here. 255.0. Okay, look at this. Enter. Okay, what are we getting? Configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as part of an AEE 802.1.10 or 802.1q or ISL VLAN. But the one that we are using is 802.1q. So meaning you cannot assign the sub interface with an IP address without enabling the trunking protocol. So it means, therefore, we're supposed to enable it. Enable encapsulation.1q10.1q10, which is the VLAN ID you had created on a switch. Okay, then you enter. Then you can come back with your IP address and now enter, and it will accept it. There will be no error. Okay. You don't guys, you don't enable until you finalize. You'll enable this on the main interface. I can exit this. I create another one. 20 interface G000.20, enter. Then encapsulation.1q20 to enable that traffic protocol. Then IP address will be 20.1. Okay, enter. So I'm through with those sub interfaces. Now I can go back to the main interface and enable interface G0/0/0. Okay, then no shutdown or no shut. Okay, so that one will enable even the sub interfaces. Okay, now because this one is a trunk, you have set up the one connecting router and the switch is a trunk. Then you'll have to go back to the interface here, enable config T interface first Ethernet 05. That's what we had used. Okay, then switch port mode trunk for it to be up. If you don't enable this as a trunk on the switch, then there will be no communication. There will be no communication there. Then we need to go back to our PCs and do additional configurations, because now we have set the sub interfaces, and those sub interfaces now become the default gateways for our PCs for each subnet or for each VLAN. Therefore, for this PC and this PC, so you will go back and introduce this 172.17.10.1.1. Okay. Can copy this and paste it to the next here. Okay, here. Yep. There. .10. That's okay. Then I do the other one for this, but I love to change that 10 to 20. Okay, here. Copy paste. Then 20.1. 20.1. Okay, for this. Then you move to here 20.1 also. Remember, we're just doing the sub interfaces to serve as our default gateway for each of those sub interfaces that have been created. Therefore, guys, now here you can now go ahead and set and verify that is the one now. Last time when we did it, okay, last time when we did it, a good question coming up, I'll respond to it. Last time when I did it, it was not communicating. So can it communicate now? Let's see. Okay, routing process taking place. So expect some delay, then it can start pinging, as you can see. Okay, it's now pinging. So meaning these PCs are on different subnets or different VLANs, but now communicating because that's what we have set through a router on a stick. Okay, so the question that has just come in, why don't we use the DHCP or something? Yes, yeah, I can use the DHCP. There's no problem. But now we have a topic on how to make a router become a DHCP. That way, now it's possible. But the normal server like this won't help you to create such. It will not create you to create VLANs. You can only do it on a router on a stick. I mean, rather on a router, because you can set that. You can make that router, by the way, to act like a server. But now you'll be getting pools. But this time around, your pools will be on VLANs. It's possible. So you just need to note you have VLANs. Okay, you have VLANs. VLAN 10, 20, 30, okay, being set on each. So it will be possible to work it out when using this router. So convert this router to act like a server. Then you can go ahead and create your VLANs and sub interfaces. Then your PCs now would be able to be assigned automatically based on the pool or based on the servers or based on rather on the VLANs where they are. So it's possible. Okay, possible, but not now. In the next topic that we'll be having. Okay, I don't know whether tomorrow or tomorrow but one. I'll check, but it's a topic that is coming up where we have that one as well. So guys, thank you so much for your time. Oops. I've just remembered Millicent. I don't know if the Millicent you are around. You had a challenge. Sorry for that. I'm following the other network. The other meeting, so there's no problem. Millicent, you had a challenge with your spot or something? Are you still here, Millicent? I can see this. Judah, your hand is up, okay? You have a question or something? Or this Millicent resting? Judah? Judah Kinyanjui. You can unmute. Whether you are talking, you can unmute if you are there. Judah? Okay, thank you. Thank you. It's a mistake. Okay, fine. Thank you, guys. So let's stop here, guys. Let's stop here. If we don't have any question, let's stop and let's meet tomorrow with more sessions. Thank you so much. Enjoy the rest of the evening. Bye.